So here is the pre-quiz video key. So number one, you're using the remainder theorem. So when you use the remainder theorem with synthetic division, what you're trying to find is f of k when k equals 2. So you're trying to really find f of 2, trying to find out what does that equal. So you could normally just do that by plugging in 2 in for your x's and evaluating what it is, but we can use synthetic division. That's what the remainder theorem is about, with synthetic division. So you take your coefficients, make sure they're all counted for, x to the third, x to the second, x to the first, x to the 0. Put a 0 in that first row there, or second row. What's going to go in the box here is a positive 2, because that's what your x equals or your k equals. 2 plus 0 is 2. 2 times 2 is 4. 4 minus 3 is 1. 2 times 1 is 2. 2 minus 5 is a negative 3. Negative 3 times 2 is a negative 6. Negative 6 plus 4 is a negative 2. So f of 2 equals negative 2. Alright, so same thing for the second one here. This time our k, what's going to go in the box, is negative 4. Coefficients are negative 1, 8. Here we're missing a linear term, just plain x, so I got to put a 0 in there for that, and then 63. 0 in that second row, add those together, negative 1. Negative 1 times 4 is positive 4, we get 12. 12 times negative 4 is a negative 48. Negative 48. Negative 48 times 4 is 190 something, I believe. 192, I believe. Yep, 192. So 192 and 192 plus 63 is 255. So f of negative 4, that means my x is negative 4, and my y is the remainder, is 255. Okay, same thing, kind of same thing as you're doing for number 3. Number 3, you're asked to use synthetic division to go ahead and actually divide these. This x cubed plus 7x squared plus 13x, and divided by x plus 2. So that means I need to solve for x here. So x plus 2, set that equal to 0, so x is negative 2. So that's what's going to go in the box, is negative 2. And I list my coefficients, 1, 7, 13, and I'm missing my constant, so I need to put a 0 for my constant. 0 in the second row, add those together, get 1 times negative 2, it's negative 2. Negative 2 plus 7 is a positive 5. Oops, positive 5 times 2. Negative 10. Negative 10 plus 13 is a 3. 3 times negative 2 is 6. Negative 6. Negative 6 plus 0 is negative 6. Okay, now here's where it's a little bit different, right? Because I want to find what the quotient is. I want to find out what is the answer to this division problem. Well, since we basically took x cubed divided by x, that means I get an x squared. So my degree of this polynomial that I'm going to write is going to be an x squared, and here are my coefficients of that polynomial, that quadratic, is 1x squared plus 5x plus 3. Now this is my remainder. The last one's my remainder, so it's a negative 6. You could write it two different ways. You can put minus 6 over x plus 2, because your remainder is always over what you're dividing by, my divisor. Or I could do a x squared plus 5x plus 3 plus a negative 6 over x plus 2. Either way is fine. Okay, same thing on this one. List your coefficients. We got to the fourth, to the third, to the second. We're missing a to the first, so we got to put a 0 there, and then we have our constant. So put a 0 in the first one. Here what's going to go in the box is opposite of, so minus 1 plus 1 would be 0, so minus 1 is going to go in the box. It's usually just the opposite of what's there. Add the first one, get negative 11. Negative 11 times 1 is a positive 11. Plus 2 is 13. 13 times negative 1, negative 13. So we get negative 21. Negative 21 times 1 is a positive 21. And then we add to 0, we get 21. 21 times a negative 1 is a negative 21. Plus a negative 4 is a negative 25. So we write our coefficients. You can put a plus minus 25. Okay, so we start with an x to the fourth and we divide it by x, so that's an x third. That's an x squared. That's an x. That's our constant, and then plus our remainder over what we divided by, x plus 1. So there is our answer for that. Okay, now we are doing quadratics. So we're finding the vertex. Remember, it's always opposite of the inside, so we're looking at the inside and it's always opposite. So our vertex is a positive 1, and then the outside always stays the same, so positive 2. Our axis is talking about the axis of symmetry, and it's always a vertical line, so it's x equals, and it's the x value of our vertex. So x equals 1. It's the whole thing. X equals 1. Not just 1, it's x equals 1 because it's a vertical line. Okay, and then our y-intercept, we plug in 0 in for x. So we're going to plug in 0 here. 0 minus 1 is negative 1. Negative 1 squared is 1. And 1 plus 2 is 3. Okay, so now we can graph this. We go over 1 up 2. And then we can graph our y-intercept, 0, 3. And then we can use our axis of symmetry. We don't really need to graph this axis of symmetry, but we can use it. Because then all we have to do is just fold it over so it's 1 away from here. So if I go 1 on the other side, I can finish my parabola. So there's the graph. Okay, other one, opposite of the inside, so that is negative 3. Keep the outside the same, so there's the vertex. Then our axis is always x equals the x value of our vertex, so x equals negative 3. That's the axis of symmetry, or just the axis. And then our y-intercept would be plugging in 0 in for x. 0 plus 3 is 3. 3 squared is 9. Then I have to times it by this negative. So negative 9, and negative 9 plus 1 is a negative 8. So I plugged in 0, I got negative 8 out. And then we can go ahead and graph that. So we went over negative 3, 1, 2, 3, and then we're down 1, I believe. Oh, up 1, sorry. Just trying to remember. So over 3 to the left, up 1, put your point, then we go 0 or negative 8, so we need to add an extra line here because there's only 7. So we can put an 8 down here, and then we fold it over that axis of symmetry that runs through here. So it's over 3, so if I go 3 more this way and go down 8, so there would be my graph. And really, I could put in another point. I could plug in negative 2 and plug that in for my x and see what I get out if you wanted to. So you could do any other points that you want to, but all you need is 3. Okay, now let's go ahead and determine the range, the domain, and the increasing and decreasing. Okay, parabolas, the range or the domain is always negative infinity to positive infinity. So for both of these, because they're both parabolas, all polynomials, most all polynomials, the degree is from negative infinity to positive infinity. And then the range, so there's the domain of both of them. The range is our y values, right? And we always read domain. Domain is from left to right, but range is from the bottom to the top, okay? So as I look at these graphs, I want to look from the bottom up. And what is my first y value? My first y value is 2. And I do have a y value of 2, so I need to put that in a bracket, 2. Then as I continually go up, I still have y values, right? As I continually go up, and this arrow is pointing up, so I continually have y values. So up to positive infinity. And the range for the second one here, I have y values down here, right? Because these arrows are pointing down. So I have y values down here, and it keeps on going down and down and down. So negative infinity. And as I go up, right, because I always read range from bottom to top. So as I go from the bottom to the top, what's my highest y? That would be this y at positive 1. So you notice kind of where we got those numbers from. I got this number 2 from the y value of my vertex, and I got this y value 1 from the y value of my vertex. So it just depends. If it faces down, then it's going to go from negative infinity until that y value of vertex. And if it faces up, it starts at that y value. And it's going to go to positive infinity. So that's actually with all even ones. The even ones are, they're sort of a little different because a quadratic only has one vertex, the lowest point with a to the fourth or to the sixth. It might have, it still kind of technically has one vertex, but there's some hills and valleys in there. But whatever your lowest point, so that lowest y value or that highest y value. Okay, increasing and decreasing. All increasing and decreasing relates to the domain. So I have to cover, when I talk about my increase and decreasing, it has to cover the range or the interval of my domain. So increasing and decreasing, I'm looking at my x's from left to right. Where does my graph start going down? And at what x value does it stop going down? So that's right here. My graph from left to right, it's going down, and it stops going down right here. This arrow also, it tells me up, but it also tells me left. So from negative infinity to that x value, 1, it's going down, and it does hit that x value. It's going down, so that's decreasing. And since I have to cover the rest of my domain, that means I have to go from 1 to positive infinity, because my increase and decrease has to cover my domain. So I don't really have to look at the graph for the rest of it, but I can. So you can see that I go from right here, keep on going. My graph, if I could draw it at the same time as I draw this line, so as I draw this line, I'm going up in my graph. So as my x's continue, my graph is going up. So it's increasing from 1 to positive infinity. Now as I look at this one is facing down, so it's actually going up till this x value. So as I go from left to right, it's going up, going up, going up, going up, going up, stops at this x value going up. So that is from, so it's increasing from negative infinity until that x value, -3. And that would be in a bracket. And then, of course, it's got to cover all the domains, so that means it's going to go from -3 to positive infinity. So I don't even have to look at the graph. But as I do, right, as I go this way, my graph is going down. So from this x value all the way here, my graph, even when I still get out here, I have some y value way maybe down here that it's still going down. It's still going down. So you notice, where do we get these? Where did I get this 1, 1, -3, -3? That's the x value of my vertex, right? Because domain is talking about x values, increasing and decreasing is talking about x values. Okay, so find the polynomial of a function. So here are zeros. Since I have I as a root, that means that the conjugate -I would also be a root. So those are my zeros or my roots. Now I have to write my factors. So that's x minus the 0, or x minus the root. So that's x minus 2, x plus 3, x minus I, and x plus I. So now I have to multiply those two. I always want to start multiplying conjugates, so I multiply those conjugates. And only complex numbers come in conjugates or irrational, as number 12. You can see on number 12. Okay. So I multiply those first. So since they're conjugates, all I have to do is first times first. So that's x squared, and last times last, so that's -I squared. And -I squared is negative times I squared is -1. So -I squared is the same as adding 1. So this is x squared plus 1. And then I multiply these two binomials, and I get x squared plus x minus 6. And now I'm going to multiply this trinomial by this binomial, and I have to take these three and multiply them by x squared, so I get x to the 4th plus x squared plus x cubed plus x minus 6x squared. Ooh, that looks ugly in there, x squared. And then minus 6. Oops, that's a plus sign right here, sorry. There's a plus sign. Now we can combine like terms. So we get x to the 4th plus x cubed minus 5x squared plus x minus 6. So that's the answer to number 9. Number 10, same thing. If this 1 plus I is a root, that means its conjugate 1 minus I is a root. Now we got to take the factors. So that'd be x minus those roots, so x plus 2. x minus 0, which is just x. So if I distribute that x in there, I get x squared plus 2x. And now I have to take x minus these, so that's x minus a 1 minus I, and then x minus 1, right, minus 1, minus a minus I is a plus I. Right, so again, these are conjugates. This is my first term, x minus 1 times x minus 1, and then I got to do my last, negative I times a positive I, and we found out that's just adding 1. So all I have to really do is take x minus 1 times x minus 1, which is x squared minus 2x plus 1, and then I add 1 for my negative I squared. So now we can go ahead and FOIL these together. I can add these. I get plus 2 here. Okay. So now we can FOIL those out, and we get x to the 4th minus 2x cubed plus 2x squared. So that's taking all three of these and multiplying them by x squared and x. Now I take all three of those and multiply them by 2x. Sorry, I took all three of these and multiplied it by x squared. That's why I got these three. Now I got to take those three again and multiply them by 2x. And I get a positive 2x squared. Oh, well, I'm kind of doing backwards. So anyways, you just FOIL those out. And so this is what 2x cubed minus 4x squared plus 4x. So it's actually, this top one in red was taking x squared and multiplying by all three. And then the bottom one is taking 2x and multiplying by all three. Okay, then we can combine like terms. So I get x to the 4th, negative 2x cubed and positive 2x cubed. They're going to cancel. Then I get negative 2x squared plus 4x. So that would be my answer, number 10 there. Okay, if 1 minus 4i is a root, these probably should have came before number 9 and number 8 there, or number 9 and number 10, but that's okay. So if this is a root, that means it's conjugate. 1 plus 4i is an answer. And then if negative 1 plus root 3, because of that square root, that's why the conjugates are also answers, because you get, whenever you take a square root, you have plus or minus. So minus 1 minus root 3 is also another root. So always, if you have one complex number or one irrational number as an answer, the conjugate is always an answer. Okay, find the possibilities. So I got to list the factors of 12. So that's 1, 2, 3, 4, and 12. And then I got to divide them, every single one of those, divided by the factors of my lead coefficient, which is 1. But that's just 1, right? So what you can do, list your factors of your constant, which is 1, 2, 3, 4, 5. 5 of them, right? And then factors of your constant, which here is 1. And then if I multiply those, I get 5. So I should have a list of 5 numbers, and then they're all plus and minus. So that means if this was a different number, say 3, then I would have 1 and 3, and I would have a total of 10 of them. And then all their plus and minuses. But since I got a 1 in front, I'm just dividing each of these by 1, so they're going to be the same. So I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and plus or minus 12. Okay, so now, so that's the answer for 13. Now 13a, I want to actually find the actual rational roots. These are just the possible rational roots. Now I want to find the actual rational roots. So that's when I do synthetic division. Take my coefficients 1, negative 8, and positive 12. And I'm not missing anything, right, because it's a cubic, so I should have 4 terms here. 0 in my first, or my second row. Okay, and then I'm going to run these through and see which one I get. So when I run them through, I know I'm trying to get 0 at the end, so that means I need a negative 12 here. So you can kind of think, okay, what number, you kind of start running them through your head a little bit to see if I can get a negative 12. So you can start running them through. You can pick, say, let's do negative 4. Let's start with negative 4. Okay, so negative 4 times 1 is a negative 4. That's negative 5. Negative 4, or that's 20. That'd be 12. Oh, no, I'm not going to get there, right? Because I get negative, what, negative 48? And so that would be a negative 36. Okay, so the good thing about this, right, there's a lot of numbers to go through, right? 10 of them. That's a lot. So, but since I did negative 4, because this is a negative, and these alternate from positive to negative to positive to negative, that means there's going to be no number bigger than or smaller than negative 4 that is going to be a 0, right? So that means I can get rid of negative 12. So I don't even have to test negative 12. Okay, and then let's do a positive 3. So I'm going to erase those, and then we're going to do a positive 3. Okay, so let's go ahead and do a positive 3 because I want to show you something. So 1, 3, 2, 6. Positive 3. Okay, maybe a positive 4 will work. That's okay. Negative 2, negative 6, and 6. All right, so that doesn't work. And okay. So what would happen here? Say if I had a positive here and these were all positive numbers, that means nothing greater than 3 would work. Okay, but these are not all positives. Okay, so that's just if these were all positive, then nothing would work greater than 3. Okay, but there was a negative in here, so that means that positive 4 could work, or positive 12 could work. So that could help kind of eliminate some numbers if that happens. That's called the boundedness theorem. So let's go ahead and pick one that does work, right? Let's plug in 2. So we get 1, we get 2, we get 1, we get 2, we get negative 6, it's negative 12, and we get 0. So we got a 0. Woohoo! So x equals 2. So it was a cubic, so now these are squared, so this would be x squared plus 1 minus 6. So now I could try to factor this, or I could do quadratic formula to find the other two, or I could continue with synthetic division, right? So if I factor this, I would get x minus 2, x plus 3. So that my answers would be another positive 2 and a negative 3. Okay, so they're all 3. Or I could continue with synthetic division. If you continue with synthetic division, you have to test the one that you got again. So I would have to test 2 again, right? And it does work out. 1, 2, 3, 6, 0, right? It does work out again. That's why I have a multiplicity of 2 here. So those are all my rational solutions. Okay, find the possibles here. So we got to take factors of 5, which are 1 and 5. And then factors of 3, which is 1 and 3. So I got to take each one of these and divide it by 1, and then take them again and divide it by 3. So I have 2 factors here and 2 factors here. That's a total of 4. So I should have a list of 4 with their plus and minuses, right? So I have plus or minus 1, plus or minus 5. Then I got to take 1 divided by 3. So 1/3. And then 5 divided by 3. Okay, so when I do this, I always want to start with my whole numbers. So those are my answers right here. Now for B, I want to find actual rational roots. So I want to figure out which ones of these actually work. So we can list our coefficients, make sure we have them all accounted for. Cubic, squared, linear, and our constant all taken care of. 0, second row. Add them together. We want to get a negative 5 here, right, to get 0. So we can think about what can we times by 3 and then subtract 9. Somehow we need a smaller kind of number here, right? So we might want to start with maybe a positive 3 because there's some negatives in here, right? Because there's more negatives in here, I might think it's a positive, right? So a positive 3. So we get 9, that's 0, that's 0. We get 31, that's not going to get us there, right? So I didn't even have to finish it. So let's do a positive 5. So that's 15, that's 6, that's 30, there we go. Negative 1, negative 5, 0. So 5 actually works. All right, so I could continue on and find the rest of them. So I know x equals 5 works. Here I went from a cube to a quadratic, so I could use quadratic formula, or I can try to factor, right? So if I try to factor this, I get negative 3 What are the factors of negative 3 that add up to 6? Well, there is none, right? So that means that they're either irrational, because I do quadratic formula, right? My negative b, so negative 6 plus or minus the square root of b squared minus 4a, so that's 12 times times c, which is negative 1, so that'd be plus 12. So that's 48 all over 2a, so all over 6. So I could reduce this negative 6 plus or minus the square root of 48. So 16 goes into that 3 times, right? So that would be negative, so x would equal negative 6 plus or minus 4 root 3 all over 6, and then I could reduce those by 2. All three of those, because 6, 4, and 6 all could be reduced down by 2. But it's just asking for rational ones, so it's just this one. These are irrational. That's 2 irrational numbers. So once you're not able to factor it, right, there's no factors of negative 3 that add up to 6, I know it's either irrational or it's imaginary, right? And they didn't ask me for all solutions. They asked for me all rational roots, right? So that's just x equals 5. Okay. Can I scroll down? Nope. Okay, so now it's just the number of possible positives, negatives, and imaginary. So I'm asking for number of positives, number of negatives, number of imaginary. All right, so you can just make this chart. Total is the degree, which is 3. Now I count my sign change. This is a positive, this is a negative, this is a positive, this is a negative. So I count my sign changes. 1. Yes, it's a sign change. Yes, it's a sign change. Yes, it's a sign change. So that's 3. So it goes 3, then it drops down by 2, 1, and I can't drop down anymore. So I continually drop down by 2 until I get to either 1 or 0. Now I want to plug in a negative 1, and so negative 1 cubed is a negative. Negative 1 squared is a positive, and a positive times a negative 2 is a negative. Negative x, or negative 1 in for x would be a negative, and I have a negative 10. So there is no sign change here, right? They're all negative, so no sign change. So that's 0 for that. So it'd also be 0 here, because I can't decrease that by 2. And then imaginary, I need 0 imaginary to get to my total of 3, and then I need 2 for this one to get my total of 3. So there you go. Next one, count the sign change. Yes, no, yes. So there's 2 possible positives. That means I drop it down by 2 as well. And so 0. Negatives, got to put in a negative. Negative cubed is a negative. Negative times 2 is a negative. Negative squared is a positive. Positive times a negative 12 is a negative. Negative times a negative 5 is a positive, and then I have a positive 1. Okay, so I count my sign changes here. No, yes, no. So there's 1 sign change when I plugged in a negative 1, so that counts for my negatives. So I have 1 sign change, so that's 1 here. I can't decrease by 2, right? I would continue, I would put a 1 here, right? And if it was a 3, then I would put a 3 here as well, and then I would decrease it by 2, right? But since it's just 1, it can't, when I put my 1s here, I can't decrease it by 2 and get a negative 1 here. So it's just 1. All right, and I want my total. It's a cubic, so 3, 3. So I need 0 imaginary, and here I need 2 imaginary, and so there's my list.